Hello, I'm Alex Bolboaca from Mozaic Works Studios, and I'm here to answer a few questions about functional programming in C++.
Why functional programming?
Well, I think functional programming is a simpler way of writing code because we use immutable functions that don't change anything in the state, functions that are very simple, that are very easy to understand, and that most of all are predictable. In my book I use an example of you know what happens when you switch on the light when you enter a room. What happens is that the light bulb turns on and you have light. What doesn't happen is that you don't get your fridge started, you don't get your water faucet starting running, you don't get any of these things. And this is normality. This means no side effects. This is what functional programming is about. However, as programmers, we are mostly used with the other way of writing code, with a lot of side effects, with a lot of weird things happening when you call a function, and this is plain weird. So I believe we can do better. And functional programming to me is just another tool in your toolbox, something that you can learn, you can use to simplify parts of your code, or who knows, maybe all your code.
Why a book on functional programming in C++?
What happens is that C++, after a long period of being a sleepy language, started evolving very quickly. And part of this evolution has been the introduction of a new paradigm in C++, the functional programming paradigm. As you know, C++ is a multi-paradigm language. You can write procedural code, you can write low-level, highly optimized code, you can write object-oriented code, you can write meta-programming, and nowadays you can even write functional programming code. So this is why I found it as a very interesting challenge to take the things that I knew about functional programming from other languages, including Groovy and Haskell, try to use them in C++ with the new features that are available, with the lambda syntax and all the other things that have been introduced, and see how we can use these features in modern C++. In actuality, it's interesting to me that I learned functional programming through C++, because many of the things that are in STL are actually related to functional programming. So when I started learning Haskell years later, I realized that I knew a lot of things from C++. So there's actually an older connection between functional programming and C++. Only now it's much easier to write functional code in C++, and it's quite interesting to see how to build larger code bases using this paradigm.
How can a programmer learn functional programming?
So the best way that I found is to learn through examples. What happened to me is that in university I was very passionate about programming, the same as I am now. I wanted to learn a lot about programming, and I had a university course on functional programming. I think it was OCaml or something like that. The teacher was very passionate about the topic, however, it didn't relate to me in any way, so I couldn't possibly understand what he was talking about. And I believe that the main reason for this is that most books, most resources on functional programming are very close to mathematics, whereas software developers like me, they just want to get things done. If I understand the mathematical concepts behind the things that I'm using, that's fine, but first of all I care about accomplishing certain tasks, accomplishing certain solving certain problems in my code. using a new tool. Why not? So that's why all the chapters in the book are very focused on examples starting from real life problems, examples starting from things like how do I test this code, how do I write code using only immutable functions, how can I compose functions in different ways. And one very interesting example is that the book introduces you to monads without telling you that they are monads until the very end. This is one thing that I've seen explained in very complex ways in other areas of the internet, but what I really like is to go through examples, work out the examples using these new techniques, and then figure out, oh, there's a pattern here. Let's call it a monad. If we go back to the idea of programmers learning functional programming, you can start from the examples in this book, but as I mentioned already in the introduction, you can even go to take inspiration from problems from coding katas, for example, and pick one of those problems, try to solve it using only functional programming concepts, and just practice until you understand how to think differently. I tried as much as possible to explain how to think in functions, but in order to actually do that, you also have to do your own practice so that you can start thinking differently than in objects.
What are the building blocks in functional programming?
So I think the most important thing is the pure function, which is a function that returns the same outputs when it receives the same input values. This means that it doesn't depend on state, it doesn't change state, it just returns values, receives values, returns values. That's all it does. Once you start using these types of functions, the next level is to look at operations between these types of functions. And you start understanding that you can do things like partial application, where one of the parameters is bound to a value and you obtain a new function. Functional composition, where you compose two functions and obtain a new function. And with these operations, and also currying, which means when you have a function with a lot of parameters, it can decompose it into smaller functions that each receive one parameter. And if you understand these building blocks, you can use them to compose simple functions into more and more complex constructs. And these are basically the building blocks of functional programming. Now, one question is, what do you do with things like input-output, where you need to have state mutation? And the answer is, you keep them in your code, you just separate them very neatly from everything that's immutable. So, and that's why you get to have a nice construct, a nice functional design.
What are some advantages of functional programming?
So I think some of the advantages are, once you understand the syntax, once you understand the operations with functions and the building blocks, the most important advantages are that first, the functions are very easy to understand, very easy to read. They are simple because they are repeatable, so they don't have any weird things in the code. Second advantage is that you can run these functions safely in a multi-threading or multi-process world. You can parallelize the functions, and the reason is they don't use any state, they don't change any state, which means that you can safely run them in a separate process if you want. The third one is they can compose indefinitely to more and more complex structures, which means that you don't necessarily have to change a lot of your code as long as you use small functions that do one thing and that can be composed to each other. I think these are the most important things, but in addition to this, you can also take advantage of other things related to performance, because pure functions are basically a large data table of input values and output values. You can cache these values, which means that if you ever have a function that you call repeatedly with the same input values, you can immediately return the same output without computing it again. Another thing is that you can use data-driven testing to test them, or an even more advanced idea, property-based testing, where instead of testing inputs versus outputs, you define certain mathematical properties for that function. They need to hold true for all values in a specific interval or in a specific data set, and you write very simple tests that will check a lot of possibilities in your code. All these are covered in the book, along with many other interesting things about how to structure your code and how to test it, even how to do test-driven development on functional programming code. So I think you will find it a very interesting topic to look at throughout the book.
What are some issues with functional programming in C++?
Functional programming in C++, despite being now in a mainstream part of the standard, is still under development. There are some lacking features in syntax, and there are some lacking features in STL. For example, one thing that's not implemented yet is the ability to run higher level functions in parallel. This is was supposed to be part of the standard, but is not yet implemented by any STL implementation. Besides that, if you want to have code that performs really well on a low level kind of thing, so let's say you're doing embedded software or something like this, maybe functional programming is not the best idea, because in that case you need to be very close to the underlying hardware, you need to communicate with it in a specific manner and so on. However, if you need to do things like engineering applications or things where you can use more memory, that's usually where functional programming is quite useful. So my advice, as always, when it comes to performance, is to write your code, measure, and then make your own decisions. There's a whole chapter on this, which is one of the longest chapters in the book, describing methods for writing code, measuring, taking advantage of compiler optimization, and also optimizing your code in various ways. In general, you should look at functional programming as another tool in your toolbox. You don't have to use it everywhere. It's useful to know about it, but it has its limitations, and you should pay a lot of attention to especially to performance when it comes to using the constructs in C++.
What is the future of functional programming in C++?
So the good news is that there are many developments around this area. One of them is the ranges library, which has now been introduced in the standard, and it's a really good and simplified way of using higher level functions. What I believe would be nice is to have things like memoization built into a compiler. This would be really good, but these are not yet in planned in the future. However, I see that there are many small things being solved in the next versions of C++, which is great.
Where can we find the book?
The book is available on Amazon and on Pact. I think it's also available on many other stores, but those are two places where you can definitely find it. It's available in many formats. You can get it as a physical book, you can get it as a Kindle format, you can get it as EPUB, whatever you prefer. Just go and search for hands-on functional programming with C++ and you'll definitely find it in a format that's useful for you. Thank you very much and hope to hear from you after you read the book with more questions or comments.